Chapter 9. Cataracts, Wrinkles, and Dowagers' Humps. Wheat and the Aging Process. The secret of staying young is to live honestly, eat slowly, and lie about your age. Lucille Ball. Wine and cheese may benefit from aging, but for humans, aging can lead to everything from white lies to a desire for radical plastic surgery. What does it mean to get old? Though many people struggle to describe the specific features of aging, we would likely all agree that, like pornography, we know it when we see it. The rate of aging varies from individual to individual. We've all known a man or woman at, say, age 65 who still could pass for 45, maintaining youthful flexibility and mental dexterity, fewer wrinkles, straighter spine, thicker hair. Most of us have also known people who showed the reverse disposition, looking older than their years. Biological age does not always correspond to chronological age. Nonetheless, aging is inevitable. All of us age. None will escape it, though we each progress at a somewhat different rate. And while gauging chronological age is a simple matter of looking at your birth certificate, pinpointing biological age is another thing altogether. How can you assess how well the body has maintained youthfulness, or, conversely, submitted to the decay of age? Say you meet a woman for the first time. When you ask her how old she is, she replies, 25 years old. You do a double take because she has deep wrinkles around her eyes, liver spots on the back of her hands, and a fine tremor to her hand movements. Her upper back is bowed forward, given the unflattering name of Dowager's Hump. Her hair gray and thin. She looks ready for the retirement home, not like someone in the glow of youth. Yet she is insistent. She has no birth certificate or other legal evidence of age, but insists that she is 25 years old. She's even got her new boyfriend's initials tattooed on her wrist. Can you prove her wrong? Not so easy. If she were a caribou, you could measure antler wingspan. If she were a tree, you could cut her down and count the rings. In humans, of course, there are no rings or antlers to provide an accurate, objective biological marker of age that would prove that this woman is really 70-something and not 20-something, tattoo or no. No one has yet identified a visible age marker that would permit you to discern, to the year, just how old your new friend is. It's not for lack of trying. Age researchers have long sought such biological markers, measures that can be tracked, advancing a year for every chronological year of life. Crude gauges of age have been identified, involving measures such as maximal oxygen uptake, the quantity of oxygen consumed during exercise at near exhaustion levels, maximum heart rate during controlled exercise, and arterial pulse wave velocity, the amount of time required for a pressure pulse to be transmitted along the length of an artery, a phenomenon reflecting arterial flexibility. These measures all decline over time, but none correlate perfectly to age. Wouldn't it be even more interesting if age researchers identified a do-it-yourself gauge of biological age? You could, for instance, know at age 55 that by virtue of exercise and healthy eating, you are biologically 45, or that 20 years of smoking, booze, and French fries has made you biologically 67, and that it's time to get your health habits in gear. While there are elaborate testing schemes that purport to provide such an aging index, there is no single simple do-it-yourself test that tells you with confidence how closely biological age corresponds to chronological age. Age researchers have diligently sought a useful marker for age because in order to manipulate the aging process, they require a measurable parameter to follow. Research into the slowing of the aging process cannot rely on simply looking. There needs to be some objective biological marker that can be tracked over time. To be sure, there are a number of differing, some say complementary, theories of aging, and opinions on which biological marker might provide the best gauge of biologic aging. Some age researchers believe that oxidative injury is the principal process that underlies aging, and that an age marker must incorporate a measure of cumulative oxidative injury. Others have proposed that cellular debris accumulates from genetic misreading and leads to aging. A measure of cellular debris would therefore be required to yield biologic age. Still others believe that aging is genetically pre-programmed and inevitable, determined by a programmed sequence of diminishing hormones and other physiologic phenomena. Most age researchers believe that no single theory explains all the varied experiences of aging, from the supple, high-energy, know-everything teenage years, all the way to the stiff, tired, forget-everything eighth decade. Nor can biologic age be accurately pinpointed by any one measure. They propose that the manifestations of human aging can be explained only by the work of more than one process. We might gain better understanding of the aging process if we were able to observe the effects of accelerated aging. We need not look to any mouse experimental model to observe such rapid aging. We need only look at humans with diabetes. Diabetes yields a virtual proving ground for accelerated aging, with all the phenomena of aging approaching faster and occurring earlier in life: heart disease, stroke, high blood pressure, kidney disease, osteoporosis, arthritis, cancer. Specifically, diabetes research has linked high blood glucose of the sort that occurs after carbohydrate consumption with hastening your move to the wheelchair at the assisted living facility. No country for old bread eaters. Americans have lately been bombarded with a tidal wave of complex new terms, from collateralized debt obligations to exchange-traded derivative contracts, the sorts of things you'd rather leave to experts, such as your investment banking friend. Here's another complex term you're going to be hearing a lot about in the coming years: AGE, Advanced Glycation End Products. Appropriately acronymed AGE is the name given to the stuff that stiffens arteries, atherosclerosis, clouds the lenses of the eyes, cataracts, and mucks up the neuronal connections of the brain, dementia, all found in abundance in older people. The older we get, the more ages can be recovered in kidneys, eyes, liver, skin, and other organs. While we can see some of the effects of ages, such as the wrinkles in our pretend 25-year-old following Lucille Ball's advice, it does not yet provide a precise gauge of age that would make a liar out of her. Although we can see evidence of some age effects, saggy skin and wrinkles, the milky opacity of cataracts, the gnarled hands of arthritis, none are truly quantitative. Ages, nonetheless, at least in a qualitative way, identified via biopsy, as well as some aspects apparent with a simple glance, yield an index of biological decay. Ages are useless debris that result in tissue decay as they accumulate. They provide no useful function. Ages cannot be burned for energy. They provide no lubricating or communicating functions. They provide no assistance to nearby enzymes or hormones, nor can you snuggle with them on a cold winter's night. Beyond effects you can see, accumulated ages also mean loss of the kidney's ability to filter blood to remove waste and retain protein, stiffening and atherosclerotic plaque accumulation in arteries, stiffness and deterioration of cartilage in joints such as the knee and hip, and loss of functional brain cells with clumps of age debris taking their place. Like sand in your spinach salad or cork in the Cabernet, ages can ruin a good party. While some ages enter the body directly because they are found in various foods, they are also a byproduct of high blood sugar, glucose, the phenomenon that defines diabetes. The sequence of events leading to formation of ages goes like this: ingest foods that increase blood glucose. The greater availability of glucose to the body's tissues permits the glucose molecule to react with any protein, creating a combined glucose-protein molecule. Chemists talk of complex reactive products, such as Amadori products and Schiff intermediates, all yielding a group of glucose-protein combinations that are collectively called ages. Once ages form, they are irreversible and cannot be undone. They also collect in chains of molecules, forming age polymers that are especially disruptive. Ages are notorious for accumulating right where they sit, forming clumps of useless debris resistant to any of the body's digestive or cleansing processes. Thus, ages result from a domino effect set in motion any time blood glucose increases. Anywhere that glucose goes, which is virtually everywhere in the body, ages will follow. The higher the blood glucose, the more ages will accumulate, and the faster the decay of aging will proceed. Diabetes is the real-world example that shows us what happens when blood glucose remains high, since diabetics typically have glucose values that range from 100 to 300 milligrams per deciliter all through the day, as they chase their sugars with insulin or oral medications. Normal fasting glucose is 90 milligrams per deciliter or less. Blood glucose can range much higher at times. Following a bowl of slow-cooked oatmeal, for instance, glucose can easily reach 200 to 400 milligrams per deciliter. If such repetitive high blood sugars lead to health problems, we should see such problems expressed in an exaggerated way in diabetics, and indeed we do. Diabetics, for instance, are 2 to 5 times more likely to have coronary artery disease and heart attacks, 44% will develop atherosclerosis of the carotid arteries or other arteries outside of the heart, and 20 to 25% will develop impaired kidney function or kidney failure, an average of 11 years following diagnosis. In fact, high blood sugars sustained over several years virtually guarantee development of complications. With repetitive high blood glucose levels in diabetes, you'd also expect higher blood levels of ages, and indeed, that is the case. Diabetics have 60% greater blood levels of ages compared to non-diabetics. Ages that result from high blood sugars are responsible for most of the complications of diabetes, from neuropathy, damaged nerves leading to loss of sensation in the feet, to retinopathy, vision defects and blindness, to nephropathy, kidney disease and kidney failure. The higher the blood sugar and the longer blood sugars stay high, the more aged products will accumulate and the more organ damage results. Diabetics with poorly controlled blood sugars that stay high for too long are especially prone to diabetic complications, all due to the formation of abundant ages, even at a young age. Before the value of tightly controlled blood sugars in type 1 or childhood diabetes was appreciated, it was not uncommon to see kidney failure and blindness before age 30. With improved glucose control, such complications have become far less common. Large studies, such as the Diabetes Control and Complications Trial, DCCT, have shown that strict reductions in blood glucose yield reduced risk for diabetic complications. This is because the rate of age formation is dependent on the level of blood glucose. The higher the blood glucose, the more ages are created. Ages form even when blood sugar is normal, though at a much lower rate compared to when blood sugar is high. Age formation therefore characterizes normal aging of the sort that makes a 60-year-old person look 60 years old. But the ages accumulated by the diabetic whose blood sugar is poorly controlled cause accelerated aging. Diabetes has therefore served as a living model for age researchers to observe the age-accelerating effects of high blood glucose. Thus, the complications of diabetes, such as atherosclerosis, kidney disease, and neuropathy, are also the diseases of aging, common in people in their 6th, 7th, and 8th decades, uncommon in younger people in their 2nd and 3rd decades. Diabetes therefore teaches us what happens to people when glycation occurs at a faster clip and ages are permitted to accumulate. It ain't pretty. The story doesn't end at greater levels of AGEs. Higher age blood levels spark the expression of oxidative stress and inflammatory markers. The receptor for ages, or RAGE, is the gatekeeper to an assortment of oxidative and inflammatory responses, such as inflammatory cytokines, vascular endothelial growth factor, and tumor necrosis factor. Ages therefore set an army of oxidative and inflammatory responses in motion, all leading to heart disease, cancer, diabetes, and more. Age formation is therefore a continuum. But while ages form at even normal blood glucose levels, fasting glucose 90 milligrams per deciliter or less, they form faster at higher blood sugar levels. The higher the blood glucose, the more ages form. There really is no level of blood glucose at which age formation can be expected to cease entirely. Being non-diabetic does not mean that you will be spared such fates. Ages accumulate in non-diabetics and wreak their age-advancing effects. All it takes is a little extra blood sugar, just a few milligrams above normal, and voila! You've got ages doing their dirty work and gumming up your organs. Over time, you too can develop all the conditions seen in diabetes if you have sufficient age accumulation. Along with 25.8 million diabetics, there are 79 million pre-diabetics in the United States today. There are many more Americans who don't yet meet the ADA criteria for prediabetes, but still experience plenty of high blood sugars after consuming some amount of carbohydrate that increases blood sugar, that is, blood sugars high enough to trigger more ages than normal. If you doubt that blood sugars increase after eating, say an apple or a slice of pizza, just pick up a simple glucose meter from your pharmacy. Test your blood sugar 1 hour after consuming the food of interest. More often than not, you will be shocked to see how high your blood glucose soars. Remember my 2 slices of whole wheat bread experiment? Blood glucose 167 milligrams per deciliter. That's not uncommon. While eggs don't increase blood sugar, nor do raw nuts, olive oil, pork chops, or salmon, carbohydrates do. All carbohydrates, from apples and oranges to jelly beans and 7-grain cereal. As we discussed earlier, from a blood sugar standpoint, wheat products are worse than nearly all other foods, skyrocketing blood sugar to levels that rival those of a full-blown diabetic, even if you're non-diabetic. Remember, The complex carbohydrate contained in wheat is the unique variety of amylopectin, amylopectin A form distinct from amylopectin in other carbohydrates, such as black beans and bananas. The amylopectin of wheat is the form most readily digested by the enzyme amylase, thus explaining the greater blood sugar increasing property of wheat products. The more rapid and efficient digestion of wheat amylopectin means higher blood sugars over the ensuing 2 hours after consumption of wheat products, which in turn means greater triggering of age formation. If age formation was a contest, wheat would win nearly all the time, beating out other carbohydrate sources such as apples, oranges, sweet potatoes, ice cream, and chocolate bars. Thus, wheat products such as your poppy seed muffin or roasted vegetable focaccia are triggers of extravagant age production. Put 2 and 2 together. Wheat, because of its unique blood glucose increasing effect, makes you age faster. Via its blood sugar AGE increasing effects, wheat accelerates the rate at which you develop signs of skin aging, kidney dysfunction, dementia, atherosclerosis, and arthritis. What happens when you AGE? Outside of the complications of diabetes, serious health conditions have been associated with excessive production of AGEs. Kidney disease. When AGEs are administered to an experimental animal, it develops all the hallmarks of kidney disease. AGEs can also be found in human kidneys from persons suffering from kidney disease. Atherosclerosis. Oral administration of AGEs in both animals and humans causes constriction of arteries, the abnormal excessive tone, endothelial dysfunction of arteries associated with the fundamental injury that lays the groundwork for atherosclerosis. AGEs also modify LDL cholesterol particles, blocking their normal uptake by the liver and routing them for uptake by inflammatory cells in artery walls, the process that grows atherosclerotic plaque. AGEs can be recovered from tissues and correlated with plaque severity. The higher the age content of various tissues, the more severe the atherosclerosis in arteries will be. Dementia. In Alzheimer's dementia sufferers, brain age content is threefold greater than in normal brains, accumulating in the amyloid plaques and neurofibrillary tangles that are characteristic of the condition. In line with the marked increase in age formation in diabetics, dementia is 500% more common in people with diabetes. Cancer. While the data are only spotty, the relationship of ages to cancer may prove to be among the most important of all age-related phenomena. Evidence for abnormal age accumulation has been identified in cancers of the pancreas, breast, lung, colon, and prostate. Male erectile dysfunction. If I haven't already gotten the attention of male listeners, then this should do it. Ages impair erectile capacity. Ages are deposited in the portion of penile tissue responsible for the erectile response, corpus cavernosum, disabling the penis's ability to engorge with blood, the process that drives penile erections. Eye health. Ages damage eye tissue, from the lens, cataracts, to the retina, retinopathy, to the lacrimal glands, dry eyes. Many of the damaging effects of ages work through increased oxidative stress and inflammation, 2 processes underlying numerous disease processes. On the other hand, recent studies have shown that reduced age exposure leads to reduced expression of inflammatory markers such as C-reactive protein, CRP, and tumor necrosis factor. Age accumulation handily explains why many of the phenomena of aging develop. Control over glycation and age accumulation therefore provides a potential means to reduce all the consequences of age accumulation. AGEs, inside and out. While we focus so far on AGEs that form in the body and are largely derived from consumption of carbohydrates, there is a second source of AGEs that come directly from the diet, animal products. This can get awfully confusing, so let's start from the beginning. AGEs originate from 2 general sources. Endogenous AGEs. These are the AGEs that form within the body, as we've discussed. The main pathway to forming endogenous AGEs starts with blood glucose. Foods that increase blood glucose increase endogenous age formation. Foods that increase blood glucose the most trigger the greatest age formation. This means that all carbohydrates, all of which increase blood glucose, trigger endogenous age formation. Some carbohydrates increase blood glucose more than others. From an endogenous age viewpoint, a Snickers bar triggers age formation only modestly, while whole wheat bread triggers ages vigorously, given the greater blood glucose increasing effect of whole wheat bread. Interestingly, fructose, another sugar that has exploded in popularity as an ingredient in modern processed foods, increases age formation within the body up to several hundredfold more than glucose. Occurring as high fructose corn syrup, fructose often accompanies wheat in breads and baked products. You will be hard-pressed to find processed foods not containing fructose in some form, from barbecue sauce to dill pickles. Also note that table sugar, or sucrose, is 50% fructose, the other 50% being glucose. Maple syrup, honey, and agave syrup are other fructose-rich sweeteners. Exogenous ages. Exogenous AGEs are found in foods that enter the body as breakfast, lunch, or dinner. In contrast to endogenous ages, they are not formed in the body, but are ingested preformed. Foods vary widely in their age content. The foods richest in ages are animal products, such as meats and cheese. In particular, meats and animal products heated to high temperature, that is, boiling and frying, increase age content more than 1,000-fold. Also, the longer an animal product food is cooked, the richer its age content becomes. An impressive demonstration of the power of exogenous ages to impair arterial function was demonstrated when identical diets of chicken breast, potatoes, carrots, tomatoes, and vegetable oil were consumed by two groups of diabetic volunteers. The only difference, the first group's meal was cooked for 10 minutes by steaming or boiling, while the second group's meal was cooked by frying or broiling at 450 degrees Fahrenheit for 20 minutes. The group given food cooked longer and at a higher temperature showed 67% reduced capacity for arterial relaxation, along with higher age and oxidative markers in the blood. Exogenous ages are found in meats that are also rich in saturated fat. It means that saturated fat was wrongly accused of being heart unhealthy because it often occurred in the company of the real culprit, AGEs. Cured meats, such as bacon, sausage, pepperoni, and hot dogs, are unusually rich in ages. So meats are not intrinsically bad, but they can be made unhealthy through manipulations that increase age formation. Beyond the diet prescription of the wheat belly philosophy, that is, eliminate wheat while maintaining restricted intake of carbohydrates, it is wise to avoid sources of exogenous AGEs, namely cured meats, meats heated to high temperature, greater than 350 degrees Fahrenheit, for prolonged periods, and anything deep fried. Whenever possible, avoid well done and choose meats cooked rare or medium. Is sashimi the perfect meat? Cooking in water-based rather than oil-based liquids also help limit age exposure. All that said, AGE science is still in its infancy, with many details yet to be discovered. Given what we know about the potential long-term effects of ages on health and aging, however, I do not believe it is premature to start giving some thought to how to reduce your personal age exposure. Perhaps you'll thank me on your 100th birthday. The Great Glycation Race. There is a widely available test that, while not capable of providing an index of biological age, provides a measure of the rate of biological aging due to glycation. Knowing how fast or slow you are glycating the proteins of your body helps you know whether biological aging is proceeding faster or slower than chronological age. While ages can be assessed via biopsy of the skin or internal organs, most people are understandably less than enthusiastic about a pair of forceps being inserted into some body cavity to snip a piece of tissue. Thankfully, a simple blood test can be used to gauge the ongoing rate of AGE formation, hemoglobin A1C, or HbA1c. HbA1c is a common blood test that, while usually used for the purpose of diabetes control, can also serve as a simple index of glycation. Hemoglobin is the complex protein residing within red blood cells that is responsible for their ability to carry oxygen. Like all other proteins of the body, hemoglobin is subject to glycation, that is, modification of the hemoglobin molecule by glucose. The reaction occurs readily and, like other AGE reactions, is irreversible. The higher the blood glucose, the greater the percentage of hemoglobin that becomes glycated. Red blood cells have an expected lifespan of 60 to 90 days. Measuring the percentage of hemoglobin molecules in the blood that are glycated provides an index of how high blood glucose has ventured over the preceding 60 to 90 days, a useful tool for assessing the adequacy of blood sugar control in diabetics, or to diagnose diabetes. A slender person with a normal insulin response who consumes a limited amount of carbohydrates will have approximately 4.0 to 4.8% of all hemoglobin glycated, that is, an HbA1c of 4.0 to 4.8%, reflecting the unavoidable low-grade normal rate of glycation. Diabetics commonly have 8, 9, even 12% or more glycated hemoglobin, twice or more the normal rate. The majority of non-diabetic Americans are somewhere in between, most living in the range of 5.0 to 6.4%, above the perfect range, but still below the official diabetes threshold of 6.5%. In fact, an incredible 70% of American adults have an HbA1c between 5.0% and 6.9%. HbA1c does not have to be 6.5% to generate adverse health consequences. HbA1c in the normal range is associated with increased risk for heart attacks, cancer, and 28% increased mortality for every 1% increase in HbA1c. That trip to the all-you-can-eat pasta bar, accompanied by a couple of slices of Italian bread and finished off with a little bread pudding, sends your blood glucose up toward 150 to 250 milligrams per deciliter for 3 or 4 hours. High glucose for a sustained period glycates hemoglobin, reflected in higher HbA1c. HbA1c, that is, glycated hemoglobin, therefore provides a running index of glucose control. It also reflects to what degree you are glycating body proteins beyond hemoglobin. The higher your HbA1c, the more you are also glycating the proteins in the lenses of your eyes, in kidney tissue, arteries, skin, etc. In effect, HbA1c provides an ongoing index of aging rate. The higher your HbA1c, the faster you are aging. So, HbA1c is much more than just a feedback tool for blood glucose control in diabetics. It also reflects the rate at which you are glycating other proteins of the body, the rate at which you are aging. Stay at 5% or less, and you are aging at the normal rate. Over 5%, and time, for you, is moving faster than it should, taking you closer to the great nursing home in the sky. So foods that increase blood glucose levels the most and are consumed more frequently are reflected by higher levels of HbA1c that in turn reflect a faster rate of organ damage and aging. So if you hate your boss at work and you'd like to hasten his approach to old age and infirmity, bake him a nice coffee cake. Hey, it's kind of blurry in here. The lenses of your eyes are the wonderful, naturally engineered optical devices that are part of the ocular apparatus, allowing you to view the world. The words you are now reading present images, focused by the lenses on your retina, that transposed into nervous system signals interpreted by your brain as black letter images on white background. Lenses are like diamonds. Without flaws, they are crystal clear, allowing the unimpeded passage of light. Pretty damn amazing when you think about it. Flawed, however, and the passage of light will be distorted. Lenses consist of structural proteins called crystallins that, like all other proteins of the body, are subject to glycation. When proteins in the lenses become glycated and form AGEs, the AGEs cross-link and clump together. Like the little specks that can be seen in a flawed diamond, little defects accumulate in the lenses. Light scatters upon hitting the defects. Over years of age formation, accumulated defects cause opacity of the lenses, or cataracts. The relationship of blood glucose, ages, and cataracts is well defined. Cataracts can be produced within as little as 90 days in lab animals just by keeping blood glucose high. Diabetics are especially prone to cataracts, no surprise there, with as much as 5-fold increased risk compared to non-diabetics. In the United States, cataracts are common, affecting 42% of males and females between the ages of 52 and 64, and increasing to 91% between the ages of 75 and 85. In fact, no structure in the eye escapes the damaging effects of AGEs, including the retina, macular degeneration, the vitreous, the gel-like liquid filling the eyeball, and the cornea. Any food that increases blood sugar therefore has the potential to glycate the crystallins of the lenses of your eyes. At some point, injury to the lens exceeds its limited capacity for defect resorption and crystalline renewal. That's when the car in front of you is lost in a blurry haze, unimproved by putting on your glasses or squinting. Wheat-free is anti-aging. You'll recall that foods made from wheat increase blood sugar more than nearly all other foods, including table sugar. Pitting wheat against most other foods would be like putting Mike Tyson in the ring against Truman Capote. No contest, a blood sugar KO in no time. Unless you're a premenopausal size 2, 23-year-old female long-distance runner who, by virtue of minimal visceral fat, vigorous insulin sensitivity, and the advantages of abundant estrogen, enjoys little increase in blood sugar. 2 slices of whole wheat bread will likely launch your blood sugar into the 150 milligram to deciliter range or higher, more than enough to set the age-forming cascade in motion. If glycation accelerates aging, can not glycating slow aging? Such a study has been performed in an experimental mouse model with an age-rich diet yielding more atherosclerosis, cataracts, kidney disease, diabetes, and shorter lifespans compared to longer-lived and healthier mice consuming an age-poor diet. The clinical trial required for final proof of this concept in humans has not yet been performed, that is, age-rich versus age-poor diet, followed by examination of organs for the damage of aging. This is a practical stumbling block to virtually all anti-aging research. Imagine the pitch. Sir, we will enroll you in one of 2 arms of the study. You will either follow a high-age diet or a low-age diet. After 5 years, we are going to assess your biological age. Would you accept potential enrollment in the high-age group? And how do we assess biological age? It seems plausible that if glycation and age formation underlie many of the phenomena of aging, and if some foods trigger age formation more vigorously than others, a diet low in those foods should slow the aging process, or at least the facets of aging that advance through the process of glycation. A low HbA1c value signifies that less age-promoting endogenous glycation is ongoing. You will be less prone to cataracts, kidney disease, wrinkles, arthritis, atherosclerosis, and all the other expressions of glycation that plague humans, especially those of the wheat-consuming kind. Perhaps it will even allow you to be honest about your age.